we are starting actually resuming the part of machine learning after a lot of this. We have uh, went through some idea of basics of Python programming, which is going to be useful in this machine learning course in future when we will start creating models and trying to do some AI related task. So let's do one thing. Let's take a very short recap that where we stopped and then we will start from today. Okay. So this particular presentation or the slide already you have seen in previous class. What this particular screen represents, that what actually we were learning is that there is some black box. The black box basically have some knowledge by which it generates some set of rules in form of set of rules, and that set of rules can be useful in future to predict some new input. And for this we have to teach that particular box in some way. And what we have seen that we must have some input as well as some result, maybe, to showcase to the box that for this input the output should be something like this, for this set of input the output will be something like this. In this way, for various examples, from various examples, the black box can learn by itself somehow, just like we learn by ourselves by looking at the environment, right? So this is the idea that we had. Still we don't know what is there within this box, so one by one we will explore and trying to understand what is within the block box and how basically this learning is happening. So it's something like, you see, this is a very important terminology present here. Technically, when we see any object, we don't remember each and every part of the object. You see, what basically we do? We actually extract some specific inputs, or say you can say some specific properties of the of the object, and that property we actually remember. For example, if I show you a picture of a dog and I also show you a picture of a cat, you can easily discriminate them because there are difference in some properties of those two images. For example, the property can be the length or height of that particular object, which is definitely different for a dog and a cat. Maybe the you know for example, the eye, the style of the eye, and many more things is possible, right? So those property technically what we call feature. So in future, when I will use this term feature, remember we are actually talking about properties of the object. So any object can be determined by more than one properties. It's not only one property you can have. Maybe one, maybe more than one. How many properties should be optimal for understanding about the object fully? That's definitely a part of investigation, part of study. So let's move on. So we had a very small example last day, that prediction of some house price. For example, you are trying to find some house for you, want to buy it, and you don't really have any idea that what should be the price uh, you know, in some particular location or something like that. So if there is some technique which can tell you an idea that for this set of situation the price should be something like that, definitely it will be better for you before you start bargaining, right? So for example, as you can see in the left hand side, it's given the carpet area, local facility, number of bedroom, year of construction. These are, you can see, a very important properties to determine what should be the price of the house, right? So technically this is what we call feature. Okay, so here at least we can see four features which represents one single object, that is a house. Now definitely before you start predicting something based on these inputs, what you must have a learned model that has already learned from some already existing example, right? Existing example in the sense some existing houses whose carpet area, local facility, number of bedroom, year of construction and many more other features is there, is known, and also the corresponding price is known. Based on this set of inputs and this set of outputs, the model has learned somehow so that it can predict for some unknown inputs, right? That will be helpful for you. Similarly, if I go for a prediction of some native place of a person, it's just a very hypothetical problem that I have given, like based on some height or complexion or hair color, maybe we can trying to understand in from which location he has came. Is he from somewhere a hill area or a very cold place in the sense not hill, it's something like maybe towards north pole or something like that, or maybe he's from desert or not, like this. So these are few examples. Now let's take a you know let's try to understand what actually we have in the data that is basically used to teach these machine learning black boxes. So you see here that what is a training data? Training data means the data by which I give training to the model. As simple as that, right? So assume that there is some model, okay, a black box, which is not yet trained, which does not have any capability to predict something based on some input. But what we want to give a training to the black box. To do this, what we have to do? We must have at least a training data, right? And presently, up to this slide, the training data that we are describing is basically comprised of two things. One is some set of features and another is the label. For example, just assume that house price prediction. So if you consider a training data for the house price prediction, you must have that set of input features for like carpet area, number of bedroom and many more, and you must have a label in form of the price of the house, right? So it looks something like this. So the training data is something like this table, as simple as that, among which here in this particular example I have kept three features. Maybe in real life there will be many more features possible. Okay, now each and every row represents a single object, a single training example. For example, over here you see for house 1 there is an example that if the carpet area is 940 square feet, number of bedroom is 3, year of construction is 3, the house price is 65 lakh. For some another house, if it is 740 square feet but number of bedroom is 2 and year of construction is 5, it is very less, 36 lakhs. So definitely you can, mathematically what you can say, that this particular house price is somehow is a function of these three features, right? So if this level is some function of these three features, there must have some mathematical equation for that, right? But we actually don't have any idea about that particular mathematical formula. What we are trying to do, based on this data, we will try to represent that mathematical formula in a form of set of rules, so that that formula can be easily used for future prediction. Because just assume a situation that you have only these two examples and you are planning to buy a house tree whose this three feature is already known. What this particular model has to do, this particular model has to predict the level, right? And to do this particular model has only two examples. From these two examples, somehow the model has to understand what should be the uh, the relation between these three features and level, right? Once this relation is known, naturally that same relation exists for all the other houses. That means that same relation can be used to predict for some unknown houses whose house price is not known. So let's try to understand in a more in a general way, like what ultimately we have a data looks something like this. What is this? This is nothing but a single instance. See, this X is representing this house 1 or house 2 individually. Remember. And what is it? Small x1, small x2, small x3. These are actually, you can say, features. That means one particular house is represented by here n number of features. Now this value of n can vary definitely. This value of n is 3 in my example. Maybe in some another example the value of n can be 10, right? But this is only for one house. Now we have multiple houses in my training example, right? That means the training data will look something like this, that this is my first house, which is basically a vector, right? It's look like a vector, and this particular vector is combined by these three features whose particular level is there, which is capital Y1. Similarly, this is for example 2, for example house 2, and many other examples can be there till xn, that means house n. Okay, so we have n number of examples here in this training data set whose features is known for each and every houses, which is nothing but represented in this form, and whose level is also known. Now what actually you have to do? We have to find out this particular relation function. We don't know how this y is related with this x. That is actually we are trying to understand from the data, and that's actually what you can say required for machine learning. So let's come back to a picture that already you have seen. So you see here we again came back to the machine learning phase, but here there is a small difference. Here we have written labeled example. Here you see, in previous image in my previous class only I had training data set, but how training data set was look like we didn't have any idea. Now we have idea. So why I am saying it is labeled example? Because for each and every example we know what is the label. The label can be some value, label can be some binary, say like yes or no or something like that. Label can be represented in different way. But this is a labeled example, what we have seen, right? So this particular data we will give input to the model somehow, okay, and we will have some training which will finally generate a trained model, and that trained model will be used in future for predicting some level of unknown data. Why I am saying unknown? because those data has not been used to train the model. It's something like you can assume like you are doing some particular mathematical chapter, you are actually trying to solve or learning some mathematical chapter, okay, and the problem that you are solving, exact problem never come in your exam sometimes, right? What happens? Similar type of problems come, right? So the same thing like this. So when you were taught, you taught with some set of mathematical examples, which was your training data, and then your brain has been trained by that particular mathematics, and then you are utilizing your brain to solve some problem of similar type, and that problem is not known to you when you are taught. That's why those are called test data set. Okay, that's why it is written as unlabeled example, because label is not yet known. You are actually trying to find the label. I mean, here the model is trying to find what should be the label. So that's why what should be, that's why here come prediction, that's why the word come predict. Okay, so definitely predict means that maybe actual should be 10 and I'm predicting it's 9.9 or maybe 10.2 or maybe 10.01. Now definitely this prediction value, you can never uh, expect that always this particular prediction value will be always equal to the actual value. It's not possible. There will be some error. It's every time it's not possible that you will get 100 out of 100 in mathematics or any subject, right? You do some error and you lost some marks. Maybe in 100 sometimes you get 90, sometimes you get 95, sometimes you get 55, something like this. In a similar way, we also try to evaluate how good a model is based on how close my prediction is. Okay, so how close it is, how it is actually measured, that I will come later. So I'm just telling you for a moment, remember in this way.